Hello all. So in today's tutorial we are going to learn about Kubernetes. So we will be seeing the various things about Kubernetes, like what is Kubernetes, then what are the various orchestration tools which are available in comparison to as an alternative to Kubernetes, then why do we need Kubernetes and what is the difference between the virtual machine and the container, and then there we will also see the advantages, architecture, and then we will have some few commands related to Kubernetes which we can test. So let's begin. So the first thing which comes to our mind is, why do we require Kubernetes and what is Kubernetes? So Kubernetes is basically is an orchestration tool which is used to orchestrate our Kubernetes cluster. Here the word orchestration means that it helps us to manage our cluster, and then it automates the managing of our resources, that we will see later how it does that. And then coming to the next point, what are the various other orchestration tool available in the market. So these are some which are available as a alternative to Kubernetes, but since Kubernetes is an open source project and it has been extensively developed, and it is available for almost all of the cloud services. That is why Kubernetes is the most popular tool for orchestration. Then the question comes, why do we require Kubernetes or any other orchestration tool? So talking specifically about Kubernetes, here we have, it provides us various features like self-healing, then auto scaling, and several other properties like it is less resource consuming, then auto scaling is possible, and high availability is another advantage which we have with the help of Kubernetes. So these are the few points which are provided by Kubernetes, and that is why we need it. So I will copy this content from here to this point, and we will be understanding what do we mean by saying high availability, self-healing, and all these points. So before moving on to these points, let's us understand what does the technology or the virtual machine and the container are and how they differ from each other. So I have picked a diagram from the net. So what is the difference between these two is that in case of virtual machine, we know that we have a hypervisor, and below that we have our hardware or the host machine or the host server, and over that we have a hypervisor, and then we have all the virtual machine installed over it. So those who are new, you may for them how it is consuming more amount of resources, that for every guest operating system we can see that we have a OS installed over or on top of the hypervisor, and that is, if we require 3 VMs, then we will have to install 3 operating systems. So in comparison to virtual machine, if we check in containers, here you can see that over the infrastructure or over the hardware we have an operating system, and then the container software, like any container technology, for example Docker is there, and then we can have our containers, that is the executables or binaries which we want to install over it. So here we can see that we have just one operating system, and on top of that we have separate containers installed, and that saves a lot of space for us. So this is one of the advantage which is provided by container. So here we are clear about this point, that it is less resource consuming. Now for understanding self-healing and high availability and scaling, we will look into it further when we will get more into Kubernetes. So let's understand how we can practically have a working cluster for us in Kubernetes. So to understand this, first of all we need to understand how we are going to set up Kubernetes. So we will have a workstation. So workstation here means your own laptop. So if I talk about workstation, then you have your own laptop, and then you are going to install a Kubernetes cluster. That is, let's suppose you want to test it on Virtualbox. So I will say Virtualbox have your Kubernetes cluster, and Kubernetes cluster means control plane and the nodes. So what is control plane and what is node, we will talk about that now. So basically a Kubernetes cluster is comprising of the nodes, that is the workers, and we call them as nodes. Earlier it was also called as minions. So minions or the nodes or the worker nodes are basically the nodes which carry out the job for you. So I would say if you have Apache service running on a container, so this is your node which will actually perform the job for you. Then I would say this is a node. Then there can be similar another node. There can be one more node which have another Apache, and that will be your node 2. Okay, it is not coming here, so I will move it to this place, then tab node 2. So here you can see that you have two nodes, or you can say two workers, and inside that you have a Apache that is installed inside it. Again Apache is installed Apache is installed as a container inside a pod. So we will deep dive into pod and all this stuff later. So as of now we can understand that we have two nodes and we have Apache installed on both of them to process any request which is coming from external world or from the customers. So right now what we have is we have just two nodes which are working independently and nobody is managing them. But in Kubernetes we have a control plane which manages all these things. So we have another node that is called as your master node. So this is your master node, and it is also called as the control plane. It is the one which is called as control plane, and it is responsible for monitoring your cluster. So if I say it is if I say it is monitoring your cluster node 1 and node 2. So now this master node, how this master node monitors your nodes. So in this master node there are various services which are available. So these services are etcd, that is the database, that is key value database, which contains the information about your cluster. And in the runtime, whenever in your cluster any node goes down or any state changes there, then your master node will check in etcd database and the actual running state of the cluster, and if there is any differences, it will try to self heal itself and bring the your Kubernetes cluster into sane state. So this is the key value database which is holding your Kubernetes cluster state. Then you have schedulers, which scheduler is the component of your master node which is responsible for scheduling your pod in one of the nodes. Like I said, we have Apache services on node 1 and node 2. Let's suppose you want to have a MySQL service as well. So if that request comes to master node, then this scheduler will schedule that MySQL pod, or we can say MySQL container, on node 1 and node 2. So this is the purpose of scheduler, that it schedules any MySQL or any pod in your node, inside your node worker nodes. Then we have controller. So controller are of various types, and the purpose of controller is to check the state of your cluster and bring it to a sane state. So for example, let's take example of node controller. So if suppose there are you have given in a Kubernetes configuration that there needs to be 2 instances of Apache. So if any of the instance goes down, then it is a job of node controller to again recreate one of the nodes which is down, and so on. So this is the purpose of controller. And then finally we have API server. So this is the primary component, or one of the primary components of master node. And whenever we say, or whenever we interact with this our Kubernetes cluster, then all the requests are sent to API server, where they are validated and the further operation or various things are done via this API server. So API server is the one which is the front end for all the components of Kubernetes master node. So this is the architecture. That is a very rough architecture. So if I go to Kubernetes website, so you can visit kubernetes.io, and here you will see that in documentation you can refer to Kubernetes components. So this is the actual diagram, or the more clear diagram of your Kubernetes cluster. So here you can see that this control plane is actually the master node, and then these are the nodes on which your containers or your pods run. And in this pod again we have several containers, or sorry, inside this node we have several containers, and each container is deployed inside a pod. So pod is basically the minimal or the smallest unit in this Kubernetes cluster. And then we have, you can see this component, that is the API component, which is taking all the requests which are coming from the node. And this is the main what can say component of your master of your control plane, which is taking all the request, and then we have several other components like etcd scheduler and c control manager, these things. So these have been defined here, and we can go through all of these components in this page. So this is the architecture of Kubernetes cluster. So here we can, or you can go through all these details about the Kubernetes cluster. Now we will come to the back to our slide. Then now we are going to have a practical session where we will be setting up a Kubernetes cluster. So to set up a Kubernetes cluster, again, if we see here, then we have various ways in which we can try out Kubernetes. So here we can see that we have a minikube, then we have a QADM set up a K8 cluster, that is QADM. So QADM is a little bit more tougher as compared to minikube, and minikube is a single master and master worker node, single master single worker node configuration, which we can set up much easily as compared to QADM, because here we have to install all the components separately, and this we can take up later. So as of now, what we will do is we will set up a Kubernetes cluster of a single master and single worker node, and then we will install kubectl on our system, and then we will interact with this minikube cluster using this command line tool, that is kubectl, and perform various operations. So let's start. So to install minikube, we have to click this hello minikube and then minikube start, and here you will see that what all things you need. So basically I have this configuration available with my laptop. So what I will do is I will just copy these two commands, and then what I will do is I will copy it here. So I have already copied these commands here. So what you have to do is you have to just run these commands as they are given, and then you will get minikube installed on your system. Like I have already installed this minikube, so you can see now I have minikube available. And if I do which minikube, so it is showing that I have minikube installed on my system, and that is located inside user local build minikube. So there are basically two commands. One is to download this minikube using curl, and then the second command is saying that install this minikube inside this user local bin minikube. So you can see that now minikube is available inside this location. So now we have minikube. Now before starting this minikube, we will install the kubectl, that is a command line tool which is used to interact with this minikube. So we will go back to, or we will just open a new tab, and here we will go to again kubernetes.io, and then we will go to documentation, and then to this kubectl, and we have to install it on Linux since my operating system is Linux. If you have any other operating system, you can follow the instruction accordingly. So using curl I can install Linux. So this is the first command which we have to run, and this is what it is doing is it is downloading this kubectl command line from this website, and download the latest version. If you want to download any specific version, you can use this command, but as of now I have used this one, so it is already present in my system. Then you have to validate the binary using this one, and then it will show you that the binary checksum, it will compare the binary checksum and the original checksum it has, and if it is equal then it will show okay. And then finally you have to install the kubectl as we did for minikube, and what it is doing is installing kubectl at the location user local bin kubectl. So coming back to my terminal, if I do which kubectl, then you can see it is already stored in my user local bin kubectl. So here our two things are done. First is installation of minikube, second thing is installation of kubectl. Now what we are going to do is we are going to install Virtualbox, because we want to install this minikube in this Virtualbox, so that if anything goes wrong with our minikube cluster, we can easily delete it inside this inside this Virtualbox, and our system is safe. So for this we will have to install Oracle VM Virtualbox. So for that, again let's go to minikube section, and here you can see that you have various options available like Docker, HyperKit and all these things. So you can use any of these containers or container manager, container or virtual machine manager according to your choice. So here I have used Virtualbox. So to download Virtualbox, we will have to click this. Once you click Virtualbox, it will take you to the location from where it will take you to the location where you can download this Virtualbox. So here you can see this is hyperlinked to you can see virtualbox.org, and from here you can download the Oracle Virtualbox as per your operating system. So again, this I have already done, so you can download it from here, and you can see I have already, okay, it is gone. So you can see I have already downloaded it for my system, and this is Virtualbox 6.1. so here you can see that you have what distribution you have. So right now I have a Linux distribution. If I click on this, it will take me to it will start downloading, or it will take me to that page from where I can download this. So this has now taken me to the page from where I can download it. So right now I have Ubuntu or operating system 2020, so that you can see check using cat etc OS release, and here you can see that I have the version 20.0.4. so here I can download the version of Virtualbox for my system, and this is 20.0.4. so I will click on this. Since it is already downloaded on my system, here you can see Virtualbox 6.1. so since it is already downloaded, I will not download it again. And once it is downloaded, we have to run sudo dpkg -i, and then name of the Debian file which we have, and then it will install the Virtualbox for us, and now you can see that Virtualbox is available. So now we have everything available for our minikube to be started. So now what I will do is I will run minikube start, and what I want to do is I want to run this minikube using our Virtualbox. So moving back to Kubernetes. So moving back to the uh, minikube page or the Kubernetes documentation page. Here we have seen that for installing or running minikube cluster on a Virtualbox, we have to use this command. So I will copy it and then paste it. And now you can see that minikube is now starting, and it is saying that it is using the Virtualbox driver based on existing profile, then starting control plane, that is a master node, control plane node minikube in the cluster minikube, and then updating the running Virtualbox minikube. Now if you will check here, you will have a earlier there was no machine. Now you will have a running instance of minikube in your Virtualbox, and that is all done by itself from with this command, and you have to do nothing. Then preparing this on Docker this. So this is how this minikube cluster is now ready, and it is running inside this Virtualbox. Now again minikube, whenever we are starting minikube, then kubectl is now configured to use minikube cluster and default namespace by default. So namespace is basically kept as default whenever we are not mentioning any namespace. That also we will see what is namespace. And then we have enabled the add-ons like storage provisioner and storage classes and dashboards. So if now you want to see your minikube dashboard, so this is what they are talking about, that you will have this minikube dashboard available. So here you can see various things like deployments, what are the pods. So here you can see that we have one pod. So I have already started one pod before this tutorial. So to check that in backend, let me quickly run kubectl get pods. So here you can see hello minikube is one of the pods which is visible, and this is same hello minikube, and then the ID is 7ktg at the end. So this is the same which it is showing at the front end. So it is one of the add-ons which is available in minikube and has been installed or added with this minikube installation. Then we have storage provisioner and default storage class that we will see later, because that is more advanced topic. So that is all for this video. Thank you, and if you have any doubts till now, then please do comment on the video. So thank you.